Good morning, class. This is the second lecture I'm recording for Math 1A. It's section 1-6, Reasoning in Algebra and Geometry. Okay? Basically, key concepts. You have these are the properties of equality. And for Math 1, you should realize you already know these because you've used them in Math 1. Supposedly. Whether or not you have, I don't know. Basically, if A equals B, for example, if you have X equals 2, then X plus 3 equals 2 plus 3. Notice if I add the same number to both sides, the equality still holds. Okay, that's what this means. Silly statement. You could say 3 equals 3, then 3 plus 4 equals 3 plus 4. That's another example. We're adding to 3 the same number on both sides of the equal sign. And 3 plus 4 is 7 no matter what you do, so it's a true statement. Same thing with subtracting the same number. Same thing with multiplying by the same number. Same thing with dividing by the same number. However, when you divide, they have this caveat that the number you divide by, C in this case, cannot be equal to 0. Do you know why that's the case? Why can we not? Do you know you can't divide by 0? All right, you could try a calculator. Here, let me show you on Desmos. I highly recommend that you get Desmos. So here we go, 5 divided by 0, and look, it's undefined. You can't do it. All right. I can get into why it's undefined, but so you can divide by the same number on both sides of the equal sign, just as long as you're not dividing by 0. This is kind of a silly statement that is obvious, I think. The reflexive property just says a number equals itself. X, 5 equals 5, X equals X, Y equals Y. It's almost too crazy to even think about, but that's the reflexive property. They equal themselves. Symmetric property just means that if A equals B, then B equals A. In other words, if X equals 5, the same thing, you can also write that as 5 equals X. They mean the same thing. Okay, that's the symmetric. Transitive property is basically if A equals B and B equals C, then A equals C. So if X equals 5, or no, excuse me, if X equals Y and Y equals 10, then you can say that X equals 10. That's the transitive property. The substitution property just says if A equals B, then B can replace A in any expression. You've done this in Math 1 when you've had to evaluate like 2x plus 3 when X equals 4. You know that, at least I hope you know, that you put the 4 in for X and you get 2 times 4 plus 3. 8 plus 3 equals 11. Okay, that's the substitution property. This is one of the biggest properties in all of math, algebraically anyway. The distributive property. I often call it the rainbow. An example numerically would be if you have 3 parentheses x plus 2, you can distribute the 3, which means you multiply the 3 against the x and the 2 and get 3x plus 6. All right? That's the distributive property, or what I used to call the rainbow, because it looks kind of like a rainbow. Here's an example. Then 2x plus x equals... Okay, this is going backwards. This is factoring, if you remember that from Math 1. Factoring 2x plus x. Since they both have x, you can rewrite that as 2 plus 1 times x on the outside, which gives you 3x. You already know this because you had to use this property to combine terms and such in Math 1. All right, that's like saying, 6y plus 2y minus 4y. That equals 6 plus 2 minus 4y. That's 8 minus 4, that's 4y. Okay, that's all that means. I mean, you probably did not think of this like that, but that's exactly what you're doing. You probably just learned to combine the numbers in front, right? 6 plus 2 is 8, minus 4 is 4, and that's 4y. Problem 1 is justifying your steps. So here we go. Here's the main statement. Given the fact that AB bisects the angle RAN. Angle RAN is this angle here that I'm highlighting. So they're basically saying that this line here bisects it. So that means this angle is congruent to that angle. And we mark congruent angles with like these little ticks, like that. They each have one tick. That means they're congruent to each other. What does congruent mean? I'm starting to wish I hadn't skipped 2-1. But congruency is, or I'm sorry, 1-1. Congruency just means that both sides are equal. Okay. I'm about to lose my power on this. So that means we can say angle, that means x equals 2x minus 75. Because this line here bisects those two angles, which means the measures of those two angles are equal. So since this side is x, and that's 2x minus 75, this is the equation. Okay. So how do we solve this? Well, to solve this is going back to Math 1. You have to do the same thing to both sides of the equal sign. You might even remember that your teacher put a dashed line down the middle. So we want to get this x all by itself. You want this by itself. To do that, we're going to have to get rid of the minus 75. So what we're going to do is add 75 to both sides. I'm sorry, I'm blowing it. We want to get the x's together and then get the number over to the left. So let's get the x's together. So we have x here. We're going to subtract x. Subtract x. We have nothing here. 2x take away x is x, 1x, minus 75. Now we're going to add 75 to both sides. And now we're going to get 75 equals x. Or x equals 75. So this was given by definition of bisector. All right. Then, to go from this step to this step, we use the subtraction property of equality. Subtraction prop of equality. I'll use equal signs to equal to make, okay. And then addition property. Prop of equality. And finally, this one is the reflexive property. Basically saying if 75 equals x, then you can also say x equals 75, because this is what most students like to see. They like to see the x on the left. Oh, wow, look at that. That was odd. Okay. All right. Here's your practice. You're supposed to fill in what you're doing. We can discuss it in class. Also for this problem, here's problem 2. Using properties of equality and congruence. Basically, congruence is a geometric term. And you're talking about congruence is when you have an equal sign with a little squiggle on top, like that. That means congruent. That's a geometric. It means the same thing pretty much as equals. But congruence is a little bit stronger because if two things are congruent, the measure of the angles are equal. Oh, I don't know. It's the same thing, really. I mean, it's really nuanced. If you can't tell, geometry is one of my weakest math subjects. It takes me a bit to get into it because I just never liked it. All right, so problem 2. What is the name of the property of equality or congruence that justifies going from the first statement to the second statement? So the segment AR is congruent to segment TY. Then TY is congruent to segment TY is congruent to AR. That's the reflexive property. Oh. Wait. Wait, that's not. Is it the symmetric? Yes, I'm sorry. It's the symmetric property because there's two different sides. I mean, there's two different segments. So it's symmetric. Basically, segment AR is congruent to TY, segment TY, then segment TY is congruent to segment AR. It's the same thing as saying if x equals 5 or x equals 5, then you can also write as 5 equals x. This is the distributive property because you can see that this is the distributive right here. At least I think you can, right? It's rainbow. 3 times x is 3x. 3 times 5 is 15. So that's the distributive property. Okay, this one going from 1/4 x equals 7 to x equals 24. That is the multiplication property of equality. We're multiplying both sides by the same number. And what property justifies the statement that the measure of angle R equals the measure of angle R? That's the reflexive. Did I not write it? I did. So that's the reflexive property. All right. Just to let you know, what they want you to do here on this developing proof, fill in the reasons for the algebraic proof. So if f of 5x plus 1 equals 21, then x equals 4. And they're basically showing the steps of solving. So this was given, because that's the original equation. Going from A to B, it's a subtraction property. This is what you're supposed to do, the subtraction property of equality. And to go from 5x equals 20 to x equals 4, you're dividing. So that's the division property of equality. And you're supposed to be doing this, so I won't sit here and do more. And now that's homework. I think the rest of this is all homework or classwork, things I'll give you in class. Yeah. So there you go. I hope that was good. Talk to you soon. Vaya con Dios. Bye-bye.